This lesson is on quadrantal angles and reference angles. And the first thing, quadrantal angles are the names given to an angle whose terminal side coincides with one of the axes. In other words, it lands on an axis, not in quadrant 1, 2, 3, or 4. And so when that happens, you have these relationships here. If they ask you for the sine of one of those angles, it's just the y value of the point, cosine would be the x value of the point, and tangent would be the y value over the x value. Now, what points am I talking about? I'm talking about these here. So if the center of this circle is at 0, 0, because you notice the x and y axis are coming together there, it is saying that you're going 1 unit to the right or up or down or left. And if you go 1 unit to the right, you get 1, 0. 1 unit up, you get 0, 1. 1 unit left, you would get -1, 0. 1 unit down, you get 0, -1. And so those will be the points that we're talking about with the angles, quadrantal angles, 0, 90, 180, and 270. And then again, 360 would also fall in here. So we refer to these points to get these values. So let's practice with a few of those. I have these examples kind of arranged vertically. So the sine, the cosine, and the tangent of 90. Let's look at that first. So 90 up here has the point 0, 1. So the sine is the y value, which is 1. The cosine is the x value, which is 0. Before we go on and answer these, I'm going to write a couple things here that might help you. So if you're looking at the point x, y, the first thing that you come to is the cosine, and then the second thing is the sine. So the x value is the cosine, the y value is the sine. And the reason I wanted to write it like this is because it is in alphabetical order. Some people can't remember which goes with which. Just like a point happens to be in alphabetical order where x comes before y as it does in the alphabet, cosine would come before sine because C comes before S. It's in the same order as the alphabet, that relationship. So that's a way to remember it. The other thing is we're going to have lots of zeros here, and especially when we do tangents, some of those could end up on the bottom or the top of a fraction. If 0 ends up on the top of a fraction, that is okay. The answer is 0. If 0 ends up on the bottom of a fraction, that is no way. So that is an undefined situation. So let's come back down to the 90 degrees and remember that our point at 90 degrees is 0, 1. So our y value would be our sine, which is 1. Our x value would be our cosine, so 0. And then tangent is your y over your x, so 1 over 0. 1 over 0 is a situation that is undefined. Alright, then we'll move to the 180. So 180 right here, the point is -1, 0. So our sine is our y value, cosine is our x value, and then our tangent is y over x. 0 over -1 is 0. 270 is here at 0, -1, so the sine is the y value, the cosine is the x value, and then your tangent is your y over your x. Again, the 0 on the bottom means we are undefined. And then finally 360, we're back over here at 1, 0, and so your sine is your y value, 0, your cosine is your x value, which is 1, and your tangent is your y over your x. 0 over 1 is 0. So that is what you need to know about quadrantal angles. You could also find the cosecant, secant, and cotangent by just doing 1 over those values. So if you can find these 3 values, you can find the other 3 just by doing the flip or the 1 over situation. Before we move on to another topic, I want to also point out that you could have negative angles or angles that go around more than one time. So you have to just figure out which quadrantal angle it lines up with. So -90 would be going backwards 90, so you would be at the point 0, -1, so your sine would be the y value, which is -1. 540 is all the way around, which is 360, plus another 180, so ending up here. And the point for 180 is -1, 0. And here, this is one of those situations I was just talking about. It's cosecant. So cosecant is 1 over the sine. So this would be 1 over the sine of 540, which is the same thing as the sine of 180, so you could put 180 here if you wanted to. And so in that case, it's 0 because your y value is 0. So 1 over 0 is undefined. Okay, the next thing that we want to talk about is the reference angle. And a reference angle is an acute angle formed by the terminal side of the angle and the x-axis. And so I have a diagram here, and in each of the quadrants I'm showing you where the reference angle would be. So in the first quadrant, if you had an angle like 60 degrees, 45 degrees, something like that, it's its own reference angle. Okay, the angle that you're looking at, the black angle, and the reference angle, which is reddish here, those are the same thing. In the second quadrant, you would have gotten an angle like, say, 120 or something like that, and you would land in the second quadrant. Your reference angle would be the difference there. So if the black angle had been 120, the reference angle would be 60 because you would have to get to 180 total. But it's always, again, formed with the x-axis. Notice that the reference angle is always closest to the x-axis. In the third quadrant, something like 200, an angle of 200 would put you in the third quadrant. Its reference angle would be between that line and the x-axis. And then in the fourth quadrant, you would end up doing, again, the angle between that line and the x-axis. So this picture kind of shows you exactly where to look for your reference angle. And then you just have to remember, you know, where you are and what it should add up to. All right. Something else that you need in order to do some of these problems is the relationships on a 30, 60, 90 and a 45, 45, 90 that we worked with the other day. We are going to know these a little bit better when we get into talking about the unit circle, but for right now I'm going to give these relationships to you again. You have 1, 2 is the hypotenuse, square root of 3 is this long side over here, and then for a 45, 45, 90, 1, 1, and the square root of 2. Those will get you the values that you're going to need here in a second. All right. What we're doing, they tell us to find the exact value, in other words, not decimals, they want these square roots and things, for each of the following. And so sine 150, we are going to find what quadrant it's located in and find its reference angle and then use that value. So if you think about graphing 150, 150 is going to be somewhere in the second quadrant. And so in the second quadrant, your reference angle would be, again, close to the x-axis. You have to think, what would make that get there? This was 180. You were all the way to 150, so this is 30 degrees. And so what that means is I can rewrite this problem as sine of 30 degrees. And when I go up here to my 30 degree, sine is opposite over hypotenuse, so that is 1/2. Now, you're also going to have to check what sign it should be. In one of our previous notes, we had about the 4 quadrants and what is positive where. And it was A, S, T, C. All students take courses or Appalachian State Teachers College. This told you where things are positive. So in the first quadrant, all 6 trig functions are positive. In the second quadrant, sine is positive, and because sine is positive, its partner cosecant is positive. In the third quadrant, tangent and its partner cotangent are positive, and in the fourth quadrant, cosine and its partner secant are positive. So when I look at this, we're in the second quadrant and we did a sine. That answer should be positive because sine is positive in the second quadrant. So 1/2 should be positive, and that is my answer. All right, 225. 225 ends up in the third quadrant. So you start here, go all the way around. That is 225 degrees. So it's past the 180 mark, the angle is the acute angle closest to the x-axis, so it's this one. This would be our reference angle. And you have to figure out what that is. Well, this was 180, this is 225, so the difference between the two is 45 degrees. So that means 45 is our reference angle. And so this problem becomes the cosine of 45. So I look on my 45, 45, 90 degree triangle, and the cosine is adjacent over hypotenuse, so I have 1 over the square root of 2. I do have to rationalize there, so I get the square root of 2 over 2, and then I need to decide if I'm positive or negative. My original angle that I'm trying to figure out is in the third quadrant. In the third quadrant, tangent and cotangent are positive and everything else is negative. Since I'm finding a cosine, that means it should be negative. So negative square root 2 over 2 would be my answer. Alright, tangent 60. 60 is easy. It's in the first quadrant, and when you're in the first quadrant with an angle, it's its own reference angle. So we just have to look up, and the tangent of 60 is opposite over adjacent, so we have square root of 3 over 1, which is just the square root of 3. And in the first quadrant, everything is positive, so I don't have to even worry about that. And then for example 4, negative 780. So I have to think about that. 720 is 2 times around, so 780, that's more than 2 times around, and it's negative, so I'm going backwards. So 1, 2 times around backwards. Well, 780 is 60 more than 720, so I'm still going to be in the fourth quadrant with that. So this is negative 780. My reference angle would be between that line and the axis. And so again, 780 here, 720 here, the difference is 60 degrees. So 60 degrees says that now I'm trying to find the cosecant of 60 degrees. And cosecant would be hypotenuse over opposite, so 2 over the square root of 3. So 2 over the square root of 3, and I will have to rationalize that. So I get 2 square roots of 3 over 3, and then I need to decide if it's positive or negative. So it's cosecant, and we're in the fourth quadrant. In the fourth quadrant, cosine and secant are positive, so that means cosecant would be negative, and I just need to make my answer negative. Okay, so that's how we are going to deal with reference angles in this lesson. Alright, our final example is really just about being able to plug things into your calculator and finding the right buttons. So your calculator only has sine, cosine, and tangent as buttons, but you can be asked about positive angles, negative angles. You can be asked about the secant, cosecant, and cotangent. So how we're going to deal with that. The first of all, everything that we're dealing with so far is in degrees. So make sure you're in degree mode. Example A is just something you would type in, sine 112 degrees. You don't have to put the degree mark. It won't kill it. If you do, if you go to that angle menu and get it. But if you just put sine 112 and you're in degree mode, your calculator understands that. So 0.927 should be what you get. Now, as I just mentioned, we don't have a cosecant button, so you have to remember that cosecant is 1 over the sine. So 1 over the sine of 500. Again, just type that in. Just 1 divide sine of 500 if you don't have one of the fraction updates. So that should be 1.555. Alright, and I have just a few more for you to practice with. You can, again, have negative angles. Make sure you're using the negative symbol down at the bottom, not a minus. Tangent is a button that you have. So if you just type this in exactly as you see it, you should get negative 8.64. Secant, again, is not one that you have, so you have to remember its relationship with cosine. Secant is 1 over the cosine. So we're going to type in 1 divide cosine 351.75. Or you may have a fraction bar that makes it look exactly like you would like it to. But either way, you get 1.010. 2400, very large angle, but again, your calculator can handle it, and it's not that big of a deal. So just type that in. You should get negative 0.5. And then F, we do have degrees, minutes, and seconds on occasion. You have to remember how to get these symbols. So you'll type in sine 175. Your degree mark is under the angle menu. So that would be second apps. It's the first option. Then you'll type the 40 in and go to second apps. Get the second option. Then type the 9 in and do alpha plus to get the seconds mark. And so you do all that, you should get about 0.075 as your answer. And then finally, cotangent. Cotangent is not a button either. You have to remember its relationship with tangent. So 1 over the tangent of negative 135. And that should end up to be 1 when you type that one in. So just make sure you can type these in correctly, make sure you're getting what I'm getting, and that concludes this lesson.